Okay, I want to go through a particular example here when we're going to sketch the square root of a function here. So what do we have here? Well, we have some graph f at x is shown below and to the right. We're going to transform this graph to produce that root x function. So first part says sketch the graph of g of x, which is equal to the square root of f at x, and label all invariant points. Okay, so I kind of went through a list of steps. So step one, let's take a look here. This is our, first of all, let's identify this. This is our square root. This is root f at x. Sorry, this is f at x. We're going to graph g of x, which is the square root of that. Now, what's important to note is look at f at x. Where does f at x sit below the x-axis, aka where is f at x less than 0? So f at x is less than 0, and not including 0, because we can actually take the square root of 0. But it sits there and here. So those are some areas to consider when we're sketching our root f at x function. We'll call that g of x. So on g of x, those particular windows of or intervals will not be in our domain. So really all we have to take a look at when it comes to sketching this g of x function is what's happening here and here. Okay? So I'm just going to eliminate those highlights. So what is the next step? So we've identified where that f at x sits below the y-axis, or sorry, excuse me, the x-axis. The next step, what I would do is, let's just draw two lines here. I want to draw a line at y is equal to 0. It's just an unofficial line. And let's draw another one at y is equal to 1. An unofficial line. Okay, so why I do that is because I can identify my invariant points from where those lines intersect my my original function f, and they're going to be when y is equal to 0 and y is equal to 1. So we got 2 there, we got 2 there, and we got 2 there. So we have 6 invariant points on this particular graph. So now we can just use those points as our guide. Really, that's all it is now at this point. So what we do next is, now I want you to just think about it. Your root f at x function, your square root or your g of x function, should follow really the same kind of orientation, kind of be similar in terms of like appearance to your original function. It shouldn't be crazy different. So I'll show you what I mean when I say that. So when we're looking at these invariant points, I can also plot a few other ones here that are really, really easy to do. This guy here, if you take a look, this guy is at a y value of 4. So if I take the square root of that, that's just going to map to 2. Square root of 4 is 2. So that's that point. And then this point here, which is located at 2, so the square root of 2 is just like 1 point, maybe 1.4 or something, so that's going to map there. So now we have enough points here, we can kind of produce a graph. So this is the first piece that's really important. Between y is equal to 0 and y is equal to 1, exaggerate it for me. Let's just draw it a little bit finer. Between y is equal to 0 and y is equal to 1, it goes above. And then it's going to come up to here. And then it'll come back down to there, to that invariant point. And then again, between 0 and 1, for our y values, it's going to go above. So just exaggerate it. So that section is done because we have a dead zone kind of points where our domain is, or where we don't have any calculable values in our domain, non-real values. But let's go to our next invariant point here. Here, again, it's going to go up and above between 0 and 1, and then it'll connect with that point there. So this is our g of x. Not so bad. So now that we got a graph here, we can answer some of the following questions. So it says, first one, state the domain and range of g of x. Okay, so what I'm going to do is I'll start with the domain. I'm going to write it in interval and set notation just to kind of show you the difference between the two. So first let's do set notation. So our domain are our values x. Now it looks like our values for our g of x function are between, what is that, -7 and -3. And equal to those points too. So we're going to say that for our domain statement. And then there's another interval to consider over here. So it looks like it's going from 1 to 4. There. So there's our domain. I'm going to write this in interval notation as well. So in interval notation, we would say, okay, it's going from -7 to -3. And we have another interval here to consider. So this is more of a calculus concept, but we use this letter here. U means the union, or another word to describe that is or. 1 to 4. So those are our intervals there. All right, let's look at the range. The range here, if you take a look, it's greater than or equal to 0. And the maximum point there, it looks like it's at 2. So in set notation, y is greater than or equal to 0, less than or equal to 2, and y belongs to our set of real numbers. If you want to do that in interval notation, that one's pretty easy, between 0 and 2. All right, thank you.